Okay, so I'm gonna start now, guys. Okay, so let me make a very quick revision on what we did last time. Last time I explained RTI. This is one of the interrupts we have, and I told you RTI is used if you want to generate periodic interrupts. So all what you have to do, you have to set the time. Once you set the time, for example, here 10 milliseconds, something like that. So you are gonna have, as long as the interrupt is enabled, you are gonna have periodic interrupts every 10 milliseconds. Is that okay? And I told you the way you have to do it is, number one, for sure, you have to use this one. As for any interrupt, you have to use something like that. You have to set as an interrupt vector this way. Also, I explain how can you set the time. To set the time, you have to write some value to this register RTI-CTL, okay? And the value you have to write is, as I told you right before, this is N and this is M. So you have to write two numbers this way. One is N, the other one is M. So how can you get N and M? So if you go here in this table, here I put all the values for N. As you see here, N can take a value from 4 zeros to 4 ones. Also for M, it can take values from 3 zeros to 3 ones. So these are all the possible cases, okay? For example, if you select this one is gonna give you the minimum time. Minimum time is 0.128 millisecond or 128 microseconds. This is the minimum you can get. I cannot get less than that. To get this minimum, this is the number you have to write in M, and this is the number, so you have to write in N and M, okay? The other value you can get, if you take this value here, and this one, I told you the value is in the table, this part, so you have to divide. This is a formula, anyway, you have to use. So the table gives you this value, so you have to divide it by 8, and then you are gonna get the time out in microseconds. So anyway, so if I take this one here, guys, so this one is gonna make 10.24 millisecond. In order to get this value, this is what I have to put in M, and this is what I have to put in N, okay? So, and this one here, which is what you can see here, 1111 and 11111 here, okay? This one can give you the maximum delay or the maximum time out. And in this case, our maximum time out is 131 milliseconds. This is the maximum, okay? So, for example here, if I wanna get the maximum delay, it has to be 7F. Because 7F actually is gonna be 1111 and then 111. And always at the end has to be 0, okay? So this one is gonna give you the maximum delay, okay? So you have to write it in this register. This is one thing. The other thing here is, always for any interrupt, that's why I told you it's easy to program interrupts. Once you understand how can you do one, all of them almost the same, okay? For every interrupt, I have to tell you where is the enable bit, the bit that can use to enable or disable the interrupt. In this case, this is the enable bit is here, okay? This one here, and this one, okay? So the bit number 7, this bit is the enable bit, okay? So if you want to enable interrupts, you have to use this instruction, bit set, okay, for this register. For sure, if you wanna disable interrupt, RTI interrupt, so here you have to use bit clear, okay? But again, when I can decide to disable interrupt, if you wanna cancel, again, every interruption, your program now can have multiple tasks, several tasks, okay? Every interrupt can take care of one task. If you want to disable, if I want to stop this task for any reason, okay? So for example, I have flashing. RTI is using to do flashing. I want to cancel the flashing, okay? So you disable the interrupts. Another example, RTI is used to make a sound, the buzzer, okay? So I want to stop the sound. Okay, I thought there is a fire alarm, but it's okay now. There is no fire alarm, so I need to stop this one. So you have to disable interrupts. Anyway, so very easy. This is how you can enable or disable RTI interrupts. I told you also for any interrupt source, I have to tell you where is what we call the flag bit. Flag bit. Okay, this flag bit is when RTI trigger interrupts, and it's your responsibility. You have to write a command to clear this one It has to be in the interrupt subroutine when you serve the interrupt. So this is the one here, and you have to write it this way, okay? Here. So always, all the time, in any RTI subroutine, you have to write this command because you have to clear this bit by writing one. This is how it works. Okay. Now I wanna any question before I explain this example? Okay. Now I'm gonna give you a program. In this program, I wanna do flashing. I wanna do flashing using RTI. So what is the idea and how can we do that? I'm gonna tell you what is the idea. The idea is, look here, guys. The idea is, if I can make interrupts every 1 second, okay? So here every 1 second, okay? And then I'm gonna write in the subroutine just a very simple instruction. I'm gonna say flip LED. That's it. Make sense? So every 1 second, I'm gonna run the subroutine. So every 1 second, interrupt is triggered. I'm gonna run the subroutine. The subroutine is gonna flip the LED. So the LED is gonna be flipped every 1 second. Is that okay? Any question? If you wanna do like flashing, faster flashing, faster. So I can change this one, and instead of 1 second, I can say every half a second. So I can trigger interrupts every half a second. Is that okay, guys? But there is a problem here. What is the problem? The problem is that if you look at the maximum delay we have, the maximum delay is 130 milliseconds. So I cannot trigger every half a second. 1 second is a very long time for microcontrollers. Okay, always keep in mind. I'm saying it's a long time for this microcontroller, and this microcontroller is very slow. You cannot compare the speed of this microcontroller with your laptop. There is no way because it's too slow, right? And still 1 second is a huge time. It's a big time. Is that okay? So here, by maximum, I cannot make interrupts more than 130 milliseconds. Last time I explained how can we solve this problem. The way I'm gonna solve this problem is, yes, I'm gonna trigger interrupts every 130. Okay, so I'm gonna count. This is interrupt number 1. This is interrupt number 2. Interrupt number 3. So we start from here. Interrupt number 4. Okay. So I'm gonna count. Okay, this is interrupt 1, interrupt 2, interrupt 3. Okay, and then all the way until interrupt number 8. In interrupt number 8, I'm gonna flip LED. So I'm gonna flip the LED every 8 interrupts. Is that okay? So that's exactly what's gonna happen. The RTI is gonna trigger interrupt every 130 millisecond. Okay. In the interrupt subroutine, I'm gonna increment a counter, and then if this counter less than 8, do nothing, just leave. You got what I'm saying? That's because every 8 times 130 is almost 1 second. Is that okay? So I have to count. This is interrupt 1, interrupt 2. So I'm gonna flip. I'm not gonna flip in every interrupt. I'm gonna flip every 8 interrupts. Okay. You can use the same logic. You can use the same logic, and if I want to make flashing every half a second instead of 1 second, half a second. So it's the same idea, exactly same idea, but I'm gonna flip every 4, not every 8, every 4. Because 4 interrupts, if I use 130 millisecond, 4 interrupts are gonna make half a second, right? 8 interrupts are I'm gonna make 1 second. Okay. So using the same idea, you can even make flashing every 2 seconds, 16 interrupts. Is that okay? Any question? That's exactly what I'm gonna do now. So see how, let's explain the program now. Number 1, let's look at the programming. Okay, nothing is new. That's exactly what I explained here, guys, as you see here. So you have to use this one, okay? And as I said, you have to use exactly the same number here for RTI. Also, as you see here, I created a memory location, a memory variable. This variable is called RTI count. This one should count interrupt number 1, interrupt number 2, interrupt to count the interrupts, okay? And keep in mind, after 8 interrupts, I have to clear the counter because I have to count for another 8. Okay. So, and then all of this is the main program. So also here you have to write this one. As I said, here this one, using this one, I'm gonna set the time out to 130 millisecond using this instruction. Okay. And then you have to enable RTI interrupts. Once I finish the initialization this way, so interrupts are going to be triggered every 130 millisecond. That means every 130 millisecond, I have a subroutine. This subroutine is going to be executed every 130 millisecond. Once I finish the initialization this way. Is that okay? Let's see what is written here in the subroutine. This is the subroutine. See what is written. Number one, you have to clear the flag bit. Okay, it doesn't matter if you put it at the beginning or if you put it at the end, you put it in the middle, it doesn't matter. You have to write it. You have to write it one time. Okay, it doesn't matter where it is. Okay, so you can write it at the beginning if you want. So just in case, maybe it's a good to write it in the beginning, because if you write it late here, if interrupt happen in the middle here, so maybe I'm gonna lose it somehow, okay? Because you are gonna clear, maybe you are gonna lose it. So maybe it's a good idea in the beginning. If I'm saying if you have very quick interrupts, I'm saying just in case of quick. So in the beginning, I'm gonna clear it so that during this time, if a new interrupt comes, I'm gonna put it here. I'm gonna put one here, okay? So, but if you do here at the end, so maybe there is it was already one, and then you are gonna write another one because of the second interrupt, and then you are gonna clear it, okay? So maybe it's a little bit good idea if you have very quick interrupts to write it at the beginning. Anyway, so let's see what I'm gonna write again. Look, I'm repeating it. Listen to me. I have a subroutine. After the initialization, I guarantee that this subroutine is going to be executed every 130 milliseconds. Okay. So what's going to happen here, as you see, number one, I'm going to increment the counter because I need to count interrupt 1, interrupt 2, interrupt 3. So increment the count, and now I'm going to compare count to 8. Okay. If it is less than 8, come here and just leave. Do nothing. If it is less than 8, do nothing. Is that okay? So here, if it is less than 8. If it is equal to 8, it's gonna come here if it is equal to 8. Number one, I have to clear the counter because I need to count for another 8. Okay. Number two, I'm gonna flip the LED. Is that okay? Any questions? Any question, guys? See what happened? Every interrupt I'm going to increment the counter, okay? If the counter is an 8, come here, RTI, leave. I'm done. I shouldn't do anything, right? If it is 8, I'm going to come here. Number one, I have to flip the counter to count another 8, right? Then I'm going to flip the LED. So I'm going to flip the LED, okay? Every 8 interrupts. Look here. If I wanna make flashing every half a second, look, very minor change. I'm going to make this one 4. That's it. So that means every 4 interrupts, I'm gonna flip the LED, right? So you can make quick flashing, okay? I think that's what you have to do in the coming lab. In the coming lab, you have to do something like that, okay? Same thing, if I make this one 16, that means I'm gonna make flashing every 2 seconds. Okay, any questions here? I wanna tell you a mistake. Maybe some students do this mistake. You have to be careful about it. Here, I need a counter. I want to use a counter to count this interrupt 1, interrupt 2, interrupt 3, and so on, okay? What if here I used a memory location as a counter, okay? What if I use a register as a counter? What would happen? For example, I'm going to decide to use register B as a counter. So every time here, I'm going to come here, I'm going to say increment B. Okay? It's not going to work. Can anyone guess why it's not going to work? You cannot use a register as a counter. It has to be a memory location. Why? Yes. Raise your voice.
Because the stack doesn't pull back.
That's true. Because in interrupts, as I explained before, it's automatically, all the registers are going to be pushed, and RTI is going to pull all of them back. You know what I'm saying? So write in B whatever you want to write in B, but this value, it's not going to keep this value, because this one, I'm going to return the initial value back. You know what I'm saying? So you should not count on the registers to remember any value, because all the registers are going to get the initial value back, right? That's why you have to use a memory location here. Any questions? Okay. So here, this is just a simple program. I want to modify this one so that here I want to flip LED number 0. I want to flip one LED every 4 interrupts, and I want to flip another LED every 4 interrupts. So it's almost the same thing, nothing is new. So here, every time I'm going to increment a counter, and then I'm going to compare the counter to 4. If it is equal, so I'm going to flip one of them every 4, okay? Because this one has to be every 4, this one has to be every 8, okay? So here, if it is 4, I'm gonna flip BB0, okay? And if it is not 4, so I'm gonna compare it with 8. If it is not 8, just leave. So it's not 4, it's not 8, just leave. If it is 8, in this case, I have to flip both of them, BB0 and BB1. Is that okay? Anyway, I think it's just very simple. By this way, one LED, I can flip one LED every 4 interrupts, which means every half a second, and the other one you can do flashing for the other one, but every 1 second. Anyway, that's very simple. So, any question? Now let's see how can we do the same thing, the same program. I want to do the same program in C language. So in C language, as I said before, look here, number 1. This is the main program here. You have to use this one to do initialization. So it is just one function. This function is going to do all the initialization, okay? One more thing I want to tell you, this function, the default of this function is to do the timeout every 10 milliseconds. This is the default, every 10 milliseconds. Is that okay? So what if you need another number? So after this function, you can write something like RTI equals another number if you want, any other number. Is that okay? So yes, you can write something, this one, after the initialization here. Okay? And again, if for some reason the program does not accept this, and it happened with some boards, all what you can do, you can go inside this one. Once you go inside this one, you will see this instruction here. You will see this something like that, this one here. You will see exactly the same thing like this one. But here is going to be another number, okay? Because 7F is used if it is 130 millisecond, but this one is programmed for 10 milliseconds. Anyway, so you can just simply change this number with the number you want or you like. Anyway, so this is how it is. So you can do just initialization by writing this one. Once I write this one this way, so I can trigger interrupts every 10 milliseconds. Is that okay? Now, where is the subroutine, the interrupt subroutine? This is the subroutine here. Remember, as I told you last time, you have to use the word void all the time. You have to use the word interrupt all the time. This can be any name, whatever you like, but you have to use here number 7. Remember, in IRQ, we used number 6. So this number can tell C language what this interrupt is for. So if always in RTI, you have to use number 7. Is that okay? So then here, inside this function, inside the function here, you can use this function to clear the RTI flag. You can use this one to clear RTI flag. I want to tell you something important. You may need it, okay? So here I told you, you can go inside this one, and you can change the assembly inside this one. I want to tell you something. C language allows to run assembly code in the C language itself. I'm going to tell you how. So the way you can do it is, I can come here and I write, I can come here and write underscore ASM. This is an instruction in C language. I'm telling C language, I'm going to give you an instruction in assembly. Please run it, okay? And then I can open here this way. And then I can say move byte. So here, this one was move byte RTI-CTL7F. I'm going to say move byte 7F, comma RTI-CTL, semicolon, this way. Is that okay? So you can do it this way. You can try also, you can try to do it this way. Is that okay, guys? So C language allows to run some assembly instructions if you want, but you have underscore ESM, and then you write it this way. Okay? So here you have to clear the flag bit. To clear the flag bit, you can just use this function to do that, okay? And now, see what I did here, guys? Again, I have to use a counter. I have to count this interrupt 1, interrupt 2, interrupt 3, and so on. But this is the counter I'm going to use here, this counter, ticks, okay? So here, this one should count this interrupt 1, interrupt 2, interrupt 3, and so on. And now, because I'm triggering interrupt every 10 milliseconds, okay? So 1 second should be equivalent to 97 interrupts. It's not 8. It was 8 when the timeout was 130 milliseconds. Now it is 97, okay? So that's what I did. Every 97 interrupts. So number 1, I'm gonna flip the LED. Number two, I have to clear the counter to count another 97. Is that clear? Same idea, but here I do it in C. Same idea. So I have a counter. This one is going to count interrupt 1, interrupt 2, interrupt 3, and so on. So here, until 97 interrupts, I'm not going to do anything. Okay, but at 97 interrupts, I'm going to flip, and then I have to keep for another 97. One more thing, very important. What is that? Look here, guys. When you define this tag, very important. If you define this tag, you should not define it here. I make it global. I define it outside here. Can anyone guess what's gonna happen if I move this one inside here? So here, when I define text, I define it outside here, global. I didn't define it here inside the function as usually we do. Normally, I have to put here inside the function. Okay, when I define it, okay? But here, the way I did it, I defined it outside here, okay? So can anyone guess what is the difference if I define it here or I define it here? Is there a difference? Yes, but raise your voice. No, I'm not going to put 0, forget the 0. I'm talking about the definition, not forget the initial value. I'm talking about the definition itself. So for example, if I put here integer, you can make short integer. Let's make it integer text. Okay, what is the difference? And I put it here. Forget the initialization. I'm gonna say integer text. I'm gonna do the initialization somehow. So I'm talking about what is the difference if I define it here or I define it here. That's very easy. You should know what is this. Do you know what is the difference between global and local variables? If you define it here, it's gonna be local. Here is global. So what is the difference? Yes. That's true. If it is global, I can use it in the whole program. However, it means what he said, if it is global, I can use it in any function. I can use it in the main. It's accessible in the whole program. But this is not the case here because I'm not going to stick here. This is not the case. There is another reason. What I'm saying? You are right about the global variable. Okay. So if I put here, this is local. I can use just inside here. Okay. But this is not the case because I'm not going to use it outside here. I'm outside this one, so I'm not going to use it here. You got what I'm saying? There's another reason. I'm going to tell you guys, very important. You should learn it. Very important. Okay. Listen to me. What happens if I define a variable here in this function? Okay. If I define a variable here, once I come to the end here, this this variable is gonna vanish. So it's gonna be deleted from memory. It does not exist anymore. You got what I'm saying? So if you do, so next time when you pull it, okay. So once you come to the end here, all variables used here, if you any variables you define here, once you come to the end here, all of them are gonna be deleted from memory. They are not exist anymore. You got what I'm saying? So every time when I put the function, it's gonna make a new location in the memory, a new variable. It's not gonna be the same. It's not gonna be the same. You got what I'm saying? But if I put here outside, so this one is gonna keep the same variable. Okay, guys? Very important to learn this one. This is in general for any subroutine. For any subroutine, not only interrupters, for any subroutine, if you define some variables inside the subroutines, at the end of the subroutines, they are gone. They are deleted from memory. They don't exist anymore. Okay? If you did something that is it's gonna stay every time you put the subroutine, it has to hold the same value. It has to be global. This one. Okay? Any questions? Okay. What I'm gonna do right now, guys. So let me tell you what I did so far and what I'm gonna do, because the coming one is exactly what you are gonna do in the coming lab. What I did so far, I explained IRQ. How can you program IRQ? I explained RTI. Now I'm gonna explain a program. How can I use both of them in one program? It's very easy. So I want to use both of them in one program. How we are gonna use both of them in one program? I'm gonna tell you how. What I want to do is RTI is gonna make flashing. Okay, IRQ is connected to a switch. It's connected to a switch. Every time I press the switch, so if the flashing is on, I'm gonna make it off. If it's off, I'm gonna make it on. You got what I'm saying? So every time I push the button, you actually trigger interrupt. Every time I trigger IRQ interrupt, if flashing is on, I'm gonna make it off. If it's off, I'm gonna make it on. You got what I'm saying? So IRQ is used to stop or to run flashing. Okay. So let's think about it. What can we do? Okay, now. So let's first talk about RTI. For RTI has to do flashing. So this is the same program I have just explained right now. So for RTI, it's going to be exactly the same program I taught right now. No difference. Is that okay, guys? So. Okay, now what about IRQ? What should I write here in IRQ subroutine? What should I write here? What I have to write here is, look here, guys. If flashing is on, okay, so I have to disable, then disable RTI interrupts. Is that okay? So if flashing is working, disable RTI interrupts. So that when you disable RTI interrupts, you actually disable, you stop flashing, no flashing anymore. Okay? And I can say if flashing is off, okay? So now I'm gonna say enable RTI. That's it. Okay, guys? You know how simply we can do this? Okay? I'm gonna do this logic by two different ways. In C language, I'm going to do something like that. I'm going to check if the flashing is on. I'm going to disable RTI. If flashing is off, I'm going to enable RTI. In C language, I'm going to do logic like that. In assembly, I'm going to do another logic. Both are okay. So I'm just teaching different ways. Both are okay. In assembly, we are going to do a different thing. You know, very simple. I'm going to tell you what I'm going to do. Look here, guys. You remember this bit? Yeah, remember this one? This is IRQ. Yes, we remember this one to enable or disable. Oh, I'm sorry, not this one. This is to enable or disable IRQ. I'm not gonna change, I'm not gonna enable or disable IRQ. I'm sorry. I have to go to RTI. So here, yeah, here, look here. Yeah, here, look here, guys. This one here, yes. So this bit here, it can enable or disable RTI. You know what I'm gonna do in IRQ interrupt? Very interesting, look. What I'm gonna do in IRQ interrupt, I'm gonna say flip this bit, that's it. Okay, so when it is interrupted, I'm gonna flip the bit. If next time interrupt, so every time IRQ is interrupted, I'm gonna flip this bit. Why? Because this plate, when I flip this plate, if it is on, if the interrupt is enabled, it's going to become disabled. Disabled is going to become enabled. Is that okay? You got it? Just one bit. Enable or disable interrupts. Any questions? Yes?
That would just keep the LED at whatever state it's in, right? So if it was
Yes.
trying to turn it off, you have to then also turn the LED off.
Yeah, so that's a good question. This one is gonna stop flashing, okay? So this one is not gonna touch the LED, right? If by accident, that's a good point. But anyway, by accident, if the LED is on, it's gonna continue on, but no flashing, right? So if it is important to you, I ask you to stop flashing. But if you feel it is important to turn it off, that's very easy. All what I can do here in IRQ, I can write one command. If it is off, I'm gonna write one command to clear or to turn the LED off. If it is important to you, okay? So let's see how I programmed it here using two different ways. Then I'm gonna show a video. Okay. So what I'm gonna do, guys, right now, I'm gonna use exactly the same program I have just taught right now. This is a flashing program. I'm gonna use exactly the same program, and then I'm gonna add IRQ to this program. Okay? So exactly the same program, and then I'm gonna add IRQ. So I'm gonna show you what I added. So I'm gonna use everything here, but I'm gonna add something. So I'm gonna show you what I added. All what I added here. Yeah, here. Can you see this one? Okay. So we already have this one before. So now I have two. This is for RTI, and now I have to add this one to the previous program. This one has to be for IRQ. This is number one. Number two, I also have to add this one. This is initialization for IRQ. I have to keep the old initialization for RTI. So now I'm writing the initialization of RTI and the initialization for IRQ because I'm going to use both. That's it. Once I finish the initialization, now the two interrupters are ready to use. So they are ready to work. Okay. So RTI, I'm not going to change anything here in RTI. So this is exactly what I have just explained right now. No difference. It's exactly the same thing. So this one is going to flip the LED every 8 interrupts. Nothing new. Okay. Now let's see what I have to write here inside IRQ. Okay. So what I did here, guys. Number one. This is for debouncing, as I explained before. Number two. That's what I told you before. Here, guys. The last bit here, this bit, I'm gonna flip this bit. Yes. So I'm gonna flip this bit. Okay. Using this instruction, using XOR, as I told before, here I'm going to use XOR in this register so that I can flip the last bit. Is that okay? So every time I press the button, you are going to trigger IRQ interrupt. IRQ interrupt is going to flip this bit. Okay? By flipping this bit, you actually, if it is on, you're going to make it off. If it is off, you're going to make it on. Okay? Everything is the same. This is in assembly. How can you do the same thing in C? Okay. Now in C, number one, let's see the initialization first. In C, now I have to write this one for RTI. Also, I have to write this one for IRQ. That's it. Once I wrote these two, so it's now ready to use. And now, this one here, this is RTI. This is exactly what I have taught right now. This is exactly what I have taught right now. You have to put here number 7, as I said before. And now I am going to add another one here. This is for IRQ, right? Here I use number 7. Here I use number 6. Okay, guys. For now, what I did, I explained only two interrupters, RTI and IRQ, right? So now your program has to be written in 3 places. 3 places. In the main program, you have to write something in IRQ. You have to write something in RTI. In 3 places. Is that okay? In chapter 5, we're going to have 9 interrupters. Okay, or 8 more interrupts. Okay. So now you can add more. So here this is only 2. It's the same idea. You can add more interrupters if you want. Okay, that's how we can make big programs. Okay, because every interrupt can take care of one test, so your program can do a lot of tests. Okay, so for example, instead of flashing, I can use RTI. If, for example, there is some danger, there is some alarm. Okay, I can use RTI to run alarm. Okay, and then I can use the push button here. If the you know in the fire alarm, there is one button. When you press it, the alarm stops. Right? You can do the same thing here. So when you press this button, you trigger IRQ. IRQ is gonna stop. It's gonna stop the alarm. Okay? But the problem here I'm gonna stop it permanently. So I'm gonna stop it until you press again. Okay? It's not, you're not gonna stop it for some time, but still you can do it. You can stop it for some time and then enable it again. You can do that. Okay? But anyway, so let's see here how I'm gonna program IRQ. So let's look at IRQ. The way I'm gonna program IRQ is a little bit different than this one. You can still use this one if you want in C, but again, I wanna teach different ways. So still you can do something like that in C language, it's okay. But I wanna teach different ways. So here, what I'm gonna do here, as I told you, I'm gonna have a variable. It's called status. This variable should tell me, this is similar to what you did in the last, not last lab, I guess, last lab, yeah. When you had a variable to tell you if the LCD is on or off, right? And you have to check the variable. So it's the same thing here. I'm going to use a variable. I'm going to call it status. You can call it whatever you want to call it. So I'm going to call it status. This variable should tell me if flashing is on or off. If RTI is enabled or not. If RTI is enabled, I'm going to disable. To disable, I'm going to enable. That's exactly what it is. Look here, guys. In the very beginning, I'm going to put 0 in the very beginning because it is enabled. So 0 means it is enabled. So every time you press IRQ, I'm going to check status. If status is 0, I'm going to make it 1. If it is 1, I'm going to make it 0. So every time I press the button, if it is 0, I'm going to make it 1. If it is 1, I'm going to make it 0. Okay? Because the two values, every value, it's one value for on, one value for off. I think 0 for on, because in the very beginning I put here 0. In the very beginning it is on. 1 for off. So now if it is on, so what I'm going to do, I think the other way. So here, let's see. So here, if it is 0, I'm going to make it 1, and then I'm going to enable. So that means it was disabled in the very beginning. So I think it was disabled in the very beginning. Okay. So here, so this one means off. This one means on. Sorry, 1 means on. So here I'm going to say if it is 0, so make it 1, and then enable RTI. Else, disable RTI. So now we have two functions. These two functions, one is called RTI enable to enable RTI interrupts. The other one is RTI disable to disable RTI interrupts. Is that okay? That's it. Okay, guys? Is that clear? Okay. So let me show you the video first, and then I'm going to talk about the coming lab, because the coming lab is very easy lab, because the interrupts maybe still the beginning, you need to, so I made it very easy, the coming lab. It's about interrupts. It's just a little modification to this program. So I have to start with this program and do little modification to it, okay? I think I have two here. Yeah, this one. So let's see this one. So now it is disabled. Now I'm going to enable flashing. So flashing now is working. Flashing is working. RTI is working. Now I'm going to disable RTI. Okay. And I put a wire this way. You know, in the coming lab, you have to use a wire like this one. Okay, it's not very nice wire, but that's what I found. It was in my home. So I bought a wire. You remember I told you that's what we are going to use in the coming lab. You remember what this wire you have to use for? I'm going to tell you quickly, because that's what I told you. That's what we are going to use in the coming lab. Here, the second one here, use a different color. The second one here is IRQ. IRQ. Every time you press a button, you are going to generate a signal on pH. So for example, if I use this one, pH3, so you have to connect the external wire this way. Because every time you press the button, you are going to generate a signal like this one on pH. And then you have to bring it here to IRQ. This is IRQ so that you can trigger interrupts. That's why I'm using a wire here, okay? Any questions? Okay, guys, any question? Let's see the coming lab. So here, again, the coming lab is very simple modification to this lab and to this program. So what you have to do, number one, you have to run this program, make sure it is working. Don't forget to connect external wire, jumper, external wire. Don't forget to do that. Otherwise, if you don't do that, you are not gonna trigger IRQ interrupts. You press a button, you create a signal, a pulse like this one on pH, but this one is not gonna go to IRQ, so you are not gonna trigger IRQ interrupts. That's why you don't forget to put a jumper this way. So number one, you have to start. Number one, you have to start with this program. You have the program, run it, make sure it's working, and then modify it to do the coming lab. Okay. And by the way, the coming lab is the last lab. Anyway, maybe I will see. Maybe I'm gonna add another lab because we are gonna have only one Friday at the very end. Usually, I don't give a lab on this Friday. I make it for project. If you want to demo a project, the last Friday is a semester. Okay. So I may not, or maybe I'm gonna boost a lab, but this lab is gonna be bonus. If you want it on I will see, okay? But at least for now, this should be the last lab for now. If there is another one, it's gonna be bonus. It's not gonna be mandatory for every student, okay? Because it's gonna be in the last week. Okay, so here, let's see what this program is about, guys. Look here. Use RTI interrupt to flash the LED connected to page 0. So here, RTI should do flashing. That's exactly what we did. RTI is going to do flashing. Okay, and so let me tell you what this program is going to do and how you are going to modify it. What this program is doing, number one, RTI is doing flashing. This number one. Number two, IRQ. Every time I press it, I can stop flashing or I can resume flashing. Okay. So I want to modify it so that number one, RTI should do flashing, but I want to change IRQ a little bit. So the way I want to change it, IRQ is, okay, the system can have I want to run one of 4 tasks, okay? So here, in one task, I want to make the flashing every half a second. In a second task, if I'm second task, so I want to do flashing every 1 second, okay? If you are in task 3, so I want to do flashing every 2 seconds. Number 4, no flashing, okay, guys? So now I want to do one of 4 things. Now, right now, I'm doing one of 2, on or off, right? Flashing every 1 second or no flashing. But now I want to change IRQ so that I'm going to do one of 4 things, okay? I'm going to explain how. So if the system is here, so if the system is doing a flashing every 1 second, and I press the button, so I have to move this one to here. So if I'm in task 1, I have to move to task 2, okay? When I press the button. If you press the button again, I might have to move this one. If you press the button again, you have to come here. If you press the button again, I'm gonna come here. Is that okay? So the push button should switch between these tasks. For example, if the current task is task 1, if you are here, if the flashing every 1 second, and then the program should move to task 2 when the button is pressed. When I press the button, so now I have to run it this way. Is that okay? If the current task is 4, so the program should move to here, okay, and so on. Okay. I'm giving you a very hint here. So what should happen is that in IRQ of interrupt, all what you have to do, guys, is first you have to define a variable. It's called task. This variable, you have to define a variable called task in order to tell me which task you are running right now. Okay, and all what I have to do, is every time I press a button, I have to increment the task. So in the very beginning, task is equal to 1. When I press the button, I'm going to increment the task. So now task is equal to 2, right? When you press a button again, I'm going to increment the task to 3. When you press a button again, you increment task to 4. Once it is 4, you have to come back to 1. Okay? So here, every time I press the button, you have to increment the task by 1. And if task equal 5, so that means task it should be 1. Because after 4, it should not be 5, it should be 1. Okay? So if the task is between 1 and 3, RTI has to be enabled. So RTI has to be enabled, okay? If it is task 4, if you are in 4, so RTI has to be disabled. That's what you have to write in IRQ interrupt subroutine. That's it. That's all what you have to write. You have to define a variable called task. Every time IRQ is interrupted, you have to increment the task. You have to make sure task should not be 5. Once it is 5, it should be 1. After 4, it should come 1, not 5. Okay? One more thing here is you should enable RTI interrupts if it is between, in case of task 1 or 2 or 3. Once it is 4, so you have to disable RTI interrupts at 4. Is that okay? So now I did what IRQ has to do. Now, what RTI has to do? Very simple. What RTI has to do is very easy. Look here, guys. If I'm in task 1, so I have to flip the LED every 8 interrupts. Okay? This is in RTI. If I am in task 2, okay? So RTI has to check the variable task. It has to check the variable task. That is why your point here about global, when I asked you here, okay, about global variable. In this case, if you write in C language, task has to be global because task should be accessible by RTI and IRQ, both of them. RTI is gonna, IRQ is gonna modify, it's gonna change this variable. RTI is gonna check this variable. Okay, so anyway, so here RTI has to check this variable. If we are in task 2, if task is equal to 2, so that means, I'm sorry, this is half a second. I'm sorry, I didn't see this one. Okay, in the first one here, if I'm task 1, that means I have to flip the LED every 4 interrupts because this is half a second. Okay, other one here, if I'm in task 2, that means I have to flip it every 1 second. Okay, if it is if it is here, if it is number 3, so I have to flip it every 16. For sure, if it is 4, I'm not gonna come to the interrupt subroutine anyway. If it is 4, because it is disabled. So what I'm gonna come to RTI interrupt subroutine if it is 1 or 2 or 3. So if it is 1, so I have to every 4 interrupts, every 8 interrupts, every 16 interrupts. Is that okay? Is that clear? Any questions? Just a very simple modification to this program. So again, number one, you have to run this program. You have to make sure it's working, and then you have to delete the modification in RTI and IRQ. Okay, this is a simple program because this is the first program on interrupts. Okay, this two is gonna have also interrupts. Okay, so any questions? Okay, so now what I'm gonna do now, guys, is I'm gonna go back to chapter 3, okay, to explain 7 segment. So what I did now, I finished RTI, I finished IRQ, okay. Now I'm gonna go to chapter 3 to explain the 7 segment. As you see here, guys, we have 4 7 segment here. These 7 segment displays are connected to port B. So I'm going to explain how can you program them. If you want to display a number here, how can you display this number? Okay. So in the beginning, I'm going to explain how can you only use one of them, and then I'm going to explain how can you use more than one. So let's first talk about one. How can we use one of them? Okay. So first of all, look here, guys. First of all, you have to understand how this 7 segment the construction of this 7 segment, how it is made, this 7 segment. I'm gonna tell you how it is made. So you can see here, guys, we have segment. You can see this one, so this one here. This one is a segment, as you can see here. This one is a segment, is a segment, is a segment, is a segment, is segment, segment. So total we have 7 segments, okay? As you see here, we call this one segment A, segment B, C, D, E, F, and G. And we have a dot here, dot, okay? So anyway, let's focus on the segment. So what we can do now, guys, by turning some segment on and some segments off, you can actually display numbers from 0 to 9. Also, you can display some letters, but very few letters, for sure. Not all letters, because this one is very simple, okay? For example, I can make letter L, right? So I can, if I turn this one on and this one on, and this one, I can make letter on, letter L, something like I can make H. So but anyway, so now let's focus on numbers for now, okay? So number one, how it is connected? What is the internal structure of this 7 segment? It's very trivial, very trivial. This is exactly similar to what I explained before here. Exactly same thing. You remember when I explained the 7? Yeah, exactly same thing like this one. It's just LEDs. This one is exactly the same thing, but you know what the difference is? This one is going to be one segment. So this is A, segment B, segment C, segment D, E, and so on. So every LED is a segment, okay? And all of them are connected to this way, but here instead of PG, so they are connected to PP0. So the first one is connected to PP0. The second one is connected to PP1, PP2, PP3, okay? And again, this is similar to BJ. This one is used for enable. So if I put 0 here, so that means you enable it. If you put 1, you disable it. Same idea, exactly same thing, okay? But the only difference, if every segment here is one LED, and all of them are connected at the cathode this way, okay? So if I put here 1, I turn this one on. If I put here 0, I turn this one off, and so on, okay? So all what you have to do is, or all what you have to know is, if I want to display number 3, you have to know which segment you have to turn on and what segment you have to turn off to display number 3. If you want to display number 7, you have to know which one is on, and that's it. So that's what we call a code. So I need a code. This code, if I want to display number 5, I need a code. This code, I can put it here on port B, okay, to turn some of them on, some of them off, so that you can display number 5, okay? So, yeah, so where is this code? It's here. Look here, guys. Here. So this one connected to PB0, PB1, all the way until PP, we have 7, so they are 7, 6. And PP7, the last one, is connected to this dot. That's why all of them are 8, okay? But let's focus on the segments now. So, if I want to display number 0, look here, guys. All of them should on except G. G has to be off. And that's what I did. So it has to be 1, 1, 1, 1, and this one has to be 0. This is if you want to display number 0. I have to turn all of them on except G. It has to be off. That is why this is the code you have to use. So if you want to display number 0, I have to send this code to port B. Is that okay? Same thing if you need number 1. So here in number 1, here, B and C. So B and C. So I'm gonna turn this one on and this one is on. Everything is off. So this is the code I have to use, which is 06. So this one is for number 0. If you want to display number 1, this is the code you have to send. You have to send to port B. Okay. Same thing for all of them. For example, in number 9, all of them on except E, and that's what I did here. So this code should be 6F. Is that clear, guys? Number 1, you understand how the 7 segment display looks like from inside. It's just LEDs. Every segment is just one LED. Number 2, how can we use it? Yes, the way I have to use it is I'm gonna turn on some LED, some segments, and I'm gonna turn off some segments to make a shape. Is that okay? So that's why we should have a code like this one. Yes, I should use a code like this one. Is that okay? The way I'm gonna use this code, guys, I'm gonna create array. So this one is gonna be array. Listen to me. And now, if I wanna display number 0, I'm gonna go to element number 0, and then I'm gonna send to port B. Is that okay? So you see, element number 0, this is number, this one is gonna turn all of them on, except this one. Okay? If I want to display element number 1, I'm going to come to element 1. I'm going to take this one, send to port B. Same thing, if you want to go to element number 9, number 8, 7, and so on. Is that okay? Any question? Yes. This is how I use it. So let me summarize. How can you program one? Again, here I'm explaining only one LED, one 7 segment. Then I'm going to explain how can you program more than one. So to program one, number 1, guys, I have to enable it. You have to enable it. How can you enable it? As I told you, every 7 segment, we have PB0 for one 7 segment. We have PB1, we have PB2, and we have PB3. So we have 4 7 segments. For example, if I want to use this one, so you have to enable this PB0 by writing 0 here, okay? And again, you have to put 1s here. Because if you enable 2, you will see the number double, okay? Because all of them are connected to port B. So if I put number 7, all of them are enabled, you will see 7, 7, 7, 7, which doesn't make sense, right? So I want to display it only in one. If you want to display it in more than one, that's okay, you can do this way, but it doesn't make sense, okay, anyway. So 1 is enabled, also LEDs also connected to port B. So also you have to disable by port J, as I explained before, BG1. So this is number 1. Number two, all what you have to do is that if I want to display number 0, I'm gonna go to the table, I'm gonna get the value of element, I'm gonna go to this array or table, I'm gonna get the number in element number 0, I'm gonna send to port B. That's it, very simple, right? You will see right now how can we do that. Okay, any questions? That's how it is. Okay, how can you do something like that? I'm going to tell you programming in assembly. I'm going to tell you how. If x is pointing at the first location, okay? So I'm going to say x plus a, and a should have the digit I want to display. So if I want to display 0, so x plus 0 is going to be here. If I want to display 1, x plus 1 is going to be here. You got what I'm saying? So x is pointing at the first location. I'm gonna add x to the digit I want to display. Okay, this is gonna give me the address. Okay, so x plus 0 is gonna give me. I'm gonna take this one, send to port B. X plus 1, this is for 1. X plus 2, this is for 2. X plus 3, this is for 3, and so on. Is that okay? You will see right now how we're gonna do it. So here, what I want to do right now, guys, I want to program a 7 segment to count from 0 to 9 every 1 second. So I'm going to make a counter 0 after 1 second, 1, 2, 3, 4. So every 1 second, I'm going to increment the counter every 1 second. After 9, it's going to become 0. Here I'm programming only 1, not 2. So after 9, it's going to go back to 0 again. Okay. Let's see how can we do this. I'm going to choose a program. Okay, I'm going to choose a program. More importantly, okay, this is one task. This is a task. This task, I can put it in the main program, or I can put it in RTI. So now I'm gonna jungle from chapter 2, 3, and 4. So I'm gonna explain how can we do this. How can you use this test when you put it in the main program, and then I'm gonna go to chapter 3 to show you how can I do the same thing. But this task, I'm gonna move this task to RTI. You got what I'm saying? So anyway. So let's see how I made it. Number 1, guys, you have to create array as I told you this way, right? This is it's the same values here. Yes, because this is the code I have to send to port B. Okay, so this is for number 0, this is number 1, all the way to number 9. That's okay. And then you have to configure port B as output. You have to configure port P as output. You have to configure port J. Okay. Also, I have to disable BG1. I have to put 1 in BG1 to disable LEDs. Okay. Before we used to use bit clear. Now I'm going to use bit set because I want to disable it. Also here I'm going to put number E. Okay. Number E is 0111. Okay. Because this is PP0 is connected to one LED and these 3 are connected to the other 3 LEDs. So I'm going to only enable 1. Is that okay? Very easy, right? So this is just initialization. And now the program should start from here. Look how the program is going to work. After that, I'm going to choose a video. I'm going to explain, the C, how can you do the same thing in C language. After that, I'm going to choose a video. After that, I'm going to explain everything again, but I'm going to move to this one to RTI. Okay, this task to RTI. Okay, anyway. So let's see how it works. Number 1, in the very beginning, X is pointing here. X is pointing on the first element here, as we see. Okay, and then here, I'm gonna say move 0, X. Okay, I'm gonna move it to port B. In the very beginning, X is here. In every iteration, so I'm gonna take the value pointed by X. I'm gonna send it to port B to display this value. After 1 second, I have to increment X. I have to take this one to send to port B. After 1 second, I'm gonna increment X. Is that okay? Until the end here, and then I'm gonna bring X back to here. Let me say the idea. Listen, X is here. Take this one, send to port B to display number 0. Okay? Wait 1 second. Increment X. Take this one, send to port B. Wait 1 second. I have to keep repeating that until once I finish 9, so X has to reinitialize X to here again. Okay? So see how it works. So number 1, I'm gonna get the byte pointed by X. I'm gonna send to port B, and as you see, increment X. So in every iteration, I'm gonna increment X. I have to wait 1 second. I'm gonna wait 1 second, and then I'm gonna compare X. So here, X is gonna be here. Every time I increment, once X to come to here, so I have to reinitialize. That's what I did. So here I'm gonna compare X with the last address, here, which is the beginning address plus 10. Once X to come to here, okay. So what's gonna happen if it is not equal? If not equal, so I'm gonna come here. I'm gonna repeat again. I'm gonna take a value pointed by X. I'm gonna send to port B, and then I'm gonna increment X and keep repeating. Okay. Once X to come to the end here, so once this one is true, not false, equal. If it is equal, I'm gonna come here. This one is gonna send me to here to reinitialize X. Got it? So now I have two branches here. Two branches. This is one branch and this is one branch. This branch, if you didn't come to the end yet, so what's gonna happen? I'm gonna branch to here to take the value pointed by X, put it in port B, increment X, wait for 1 second. Keep repeating. Okay? Once X equal display plus 10, so I already display this one, I incremented X, so this is here. So I have to reinitialize it here. The way I'm gonna reinitialize it, I'm gonna branch it here. Okay? So reinitialize, then I'm gonna put it again. So what's gonna happen exactly is, look here guys. This part is gonna repeat it 10 times. From 0 to 9, 10 times. After 10 times, I'm gonna come to here to do this one, and then go inside here to do another 10 times, and so on. So here, 10 times, and then come here, reinitialize, 10 times, and so on. Is that clear? Any questions? Let me show the program before I show the assembly. How can we do the same thing? Sorry, in C. So let's see the program first. Can you see here, guys? Number 2, number 3, number 4, number 5, 6, 7, 8, 9. After 9 is gonna come 0 again, 1. So it's gonna continue. Is that okay? So, okay. So now let's see how can we do the same thing using C language. So in C language, I'm gonna explain two ideas. One idea that's very close to C, sorry, to the assembly. Okay. Another idea is by using a function. So I'm gonna do it in two different ways. So here, I created the same thing. I created an array. So here, so I'm gonna use the same idea I used in assembly. I'm gonna just repeat it here. So number one, I'm gonna have an array like this one, like this array. So I'm gonna have exactly the same thing here. So here I created an array, right? So here, this is for number 0, this is for number 1, all the way to number 9. So this is number 1. I created an array this way, okay, guys? And then you can see here, I'm gonna make a full. I'm gonna make a full loop 10 times, okay? And then see what I'm gonna do, guys. Here in the beginning, I is equal to 0, so I'm gonna get this value. I'm gonna put it here because this is array. Digits of 0 is gonna be this value, okay? And then what this one is gonna do? This is a function. This function, whatever you put here, is gonna put in port B. So whatever you give me here, I'm gonna put it in port B. And the second value here, you have to tell me which LED, which 7 segment you wanna enable. Okay. So this 0 means this function is gonna enable the 7 segment number 0. Is that okay? And then it's gonna take this value and put it in port B. Is that okay? So what's gonna happen? In the first iteration, I is 0. So it's gonna take this one here. It's gonna put this one on port B, and then always I'm gonna use 0. So it always is gonna enable display number 0. Okay. In second iteration, and then it's gonna wait 1 millisecond, and then 1 second, 1000 millisecond, and then in the second iteration, I is equal to 1. So it's gonna take this one, put it here. Is that okay? In next iteration, I is equal to 2. Take this one, put it here, and so on. So all the way to here. Once it is done, I'm gonna go back here, go back to repeat again. Is that clear? Pretty easy, right? So you can see here, I'm gonna make 10 iteration. In every iteration, I'm gonna take a different value here in every iteration. Is that okay? Is that okay, guys? Any question? So this is similar to the idea I explained in assembly. Now I'm going to explain an easier way. What is the easier way? Okay. Look here, guys. What I did here, I had to use this. I had to use this array. I had to use this array because I had to convert from a number to the code. So if it is 0, it has to be this one. If it is 1, it has to be this one. Is that okay? That's why. So you have to do the conversion by yourself. That's why I use this array. I have another function. This conversion is done internally in the function. Very easy, right? So all what you have to do, just tell me 0. And then inside the function, I'm hiding details. I'm hiding the details. You got what I'm saying? So inside the function, I'm going to take this one, and I'm going to send it to port B. You got what I'm saying? That's why this. Again, that's very easy. Look here, guys. The more I hide details, the shorter the program, okay? But sometimes it's useful to understand details because it's gonna connect you to the hardware to understand the hardware is how it is done. So this is what I'm gonna do here. So we have another function. It's different from this one. This one is called segment 7 on. The other one is called segment 7 decimal. So all what you have to do here, guys, don't give me a code. Just give me a number. So just to give me 0, I will display 0, right? If you give me 1, I'm gonna display 1. So I'm gonna do the conversion internally. You don't need to worry about the conversion, okay? So that's why this one is very easy. So here, yeah, just look how it's very easy. So all what I have to do here, guys, just I'm gonna loop 10 times. When I put 0, I'm gonna display 0. When I put 1, I'm gonna display 1, 2, 3, and so on. Is that okay? Any question? Okay. So now what I did here, I can do this test. I can move this test into RTI. Okay, I'm gonna show how if I move it to RTI, how it can be done. Okay. So now I'm gonna jump to chapter 4 because it's exactly the same thing. But here I did it in the main program. And now I want to show you how to can do it in RTI. Yeah, look here, it's exactly same program. I need to count on 17 segment from 0 to 9, and you repeat every 1 second. Is that okay? So number 1 here, as you see, guys, I have to use this table again. Yeah, I have to use this table here again. Is that okay? Okay. And then I have to use RTI count because every 1 second. So this one has to tell me RTI count. This is interrupt 1, interrupt 2, interrupt 3. So I have to, so that every 1 second means every 1 interrupt. Okay, sorry, every 8 interrupts. So in the beginning, I'm going to display this one. After 8 interrupts, I'm going to display this one. After 8 interrupts, I'm here. After 8 interrupts, I'm here. This is okay. I need another counter, this one, to tell me if I should display numbers, this one or this one or this one. Okay. So this one, so this counter should, if it is 0, I'm going to display 0. If it is 1, I'm going to display 1. So this one has to go to all the way until 9. After 9, it has to come to 0 again. So this is a digit. This is a number. Okay. And then, so this is just initialization. Initialization, nothing is new. So let's look inside RTI here, guys. Also initialization, nothing is new. This one you have to clear the flag bit, nothing is new as well. Here I have to increment RTI counter. Okay, guys. If it is not equal to 8, so I'm gonna come to here. If it is not equal to 8, so I'm gonna come to here so that I'm gonna leave. That means this part, we are gonna do this part every 8 interrupts. So every 8 interrupts, I'm gonna do this part, right? Number 1, you have to clear RTI count because I have to count for another 8. So every 8, I'm gonna clear this one to count another 8, and so. Okay. Anyway, now let's come to the interesting point. So now I have to display every 8 interrupts. That's exactly what I have to do. Every 8 interrupts, I'm gonna take this one of these, and I have to send to port B. Every 8 interrupts. In the beginning, this one has to go to port B, and then after 8 interrupts here, 8 interrupts here, 8 interrupts here, and so on. After I come here, I have to go back to here. Okay. So how I can do that? I'm gonna tell you how. All what I have X. X is here. I have X. X is pointing here. Also, I have count. Count, if count is 0, count is it is a digit. The number I want to display is the number. Okay. So if I add X plus count, this is going to give you the address. This is going to give you the code. So X is here. X plus 0. So this is the code for 0. X plus 1. X plus 2. X plus 3. X plus 4, and so on. That's exactly what I have to do. So what I'm going to do, X plus count, and this is going to give you the address for the code. I'm going to take this code, I'm going to send to port B. This is exactly what it is. Okay? So here, guys, X is going to point at the first element, okay? And then here, count is going to go to A. And then, look here, X plus A. And A is count, so X plus count. So I'm going to take the byte. I'm going to take the byte pointed by X plus count. Okay? And in this location, I store the code of the number. This is number 7, so you will find the code of 7. So I'm going to take a byte. I'm going to send to port B. And also, I'm going to increment count for next time. For next time, I'm going to increment count. And if count equal to 10, so I have to clear count. That's it. If count equal to 10, so next time I have to clear count. Any question, guys? Okay. Very important again. Okay. Keep in mind, all the registers are going to have the initial values back. That's why if you want to memorize any values here, in next interrupt, you have to use a memory location. That's why I used to use 2 memory locations, because RTI count, I need to memorize it next time. Same thing for count. Any question? Very easy, right? So this is the same thing I have just taught right now. You can put this task in the main program, or you can move it to RTI. That okay? Someone can tell me, okay, so now your code can be written in, okay, just give me 1 second. So now, based on what I explained, we have main, we have RTI, and you have IRQ. Is that okay? So you can write something here, something here, something here. So now your code can be written in 3 places. Okay? After I teach chapter 5, okay? In chapter 5, I'm going to teach a timer system, okay? In timer system, we're going to have 8 interrupts, okay? For sure, these interrupts are made for the timer. However, if you don't use all of them for timer, so you can take some of them and use them like RTI or IRQ. You can understand? That's what I'm going to explain in the next chapter. That means, next chapter, in addition to RTI and IRQ, you can have up to 8 more RTIs or IRQs. 8 more. Okay, this one I can teach. So look, imagine how microcontroller can do a big program, right? So many tasks. So now you have around 10 interrupts. For sure, you have another sources of interrupts. So now you have 10 interrupts plus the main program. So you can do a lot of things. Okay, but again, we don't do magic, right? So what I mean exactly is we have limit. There should be a limit, right? What is the limit? The limit is, number 1, if you have too many tasks, and if one task takes too much time, it's going to impact the other tasks, because the CPU has to exist somewhere here at a certain time. So if this one takes too much time, it's going to impact others, right? If you have too many at all the time, and I have to come here, and this guy has to wait me until I finish this one, and then I come here, so the system is starting slow, right? This makes sense, right? Anyway, any questions? Okay, so we're gonna continue working on interrupts on chapter 3 in Wednesday. Okay, I sent you a mail about test 2. Okay, so on Friday I'm gonna post test 2, and then you have a week to finish it. You have to do demo it next week Friday, is coming Friday next week.